Hey guys, welcome back. So I need a video to post for Friday, so I thought I'd show you something, or we're gonna go over something real quick from this whole week of testing. So we talked about all this welding, but what we never talked about is how we're actually setting up our welder, the materials we're using, things like that. So just to give you a quick rundown, I've got an Alpha Tig 201. That's our welding machine, and I'm using the that 2% thoriated tungsten. It's the red one. And then I had a number 6 cup, and we're using argon for our shielding gas. And then, let's see, we're running like a number 6 cup, so I think we had the argon at around a 12 CFM or so, about double the cup number. And that was plenty for that cup. You can actually run them at less, but if you double it, it's a pretty safe bet from what I've seen. So we were running that for our shielding gas. And then so the filler material, this is kind of a biggie. This is something I had researched quite a bit as far as like what filler you want to run. And what I ended up choosing was called ER70S2. So it's basically the 70 is a 70 KSI. I really don't remember what all the numbers stand for. I've looked it up. But anyway, it's a 70 KSI triple deoxidized filler. That's a hard word to say. And what's notable about it, when I looked it up, people said to either run the 70, the ER70S, or the ER80. And the 80 is stronger. It's a stronger KSI. So you're probably thinking like, well, obviously, if you want strong welds, you should use a stronger filler. It seems true. And in some way that could be true, but here's the thing. So I actually ran the 70 for several reasons. One, everything I read on the internet said the 70 is just easier, and there's always a divide on things, but the majority, I guess, would have agreed that the 70 is the better one to use. But if you try to compare, say the top two recommended were the 70 or the 80, well, the 80 is stronger, so it really made me want to do that. But when I started reading about it, everybody said the 70 is more ductile. And that's a big thing for a roll cage. So if I get in a wreck and I actually need this cage to, save my life, it's really important that those welds don't break. So they need to be strong, and strength is, that's important, but strength and breaking are different. So if you have a weld that's brittle, so like we did all this testing, and what we did in all the testing was we were bending metal. And so you can see like right here, let's see if you can kind of see my mouse. Yeah. So all of this is basically the fillet of the weld. And this used to be a straight piece of metal, and you can see this curves. Even here it's curving. So this is part of the weld. This weld had to bend. Now the weld is up here, but this had to bend, and then this metal had to bend. And this is called the heat affected zone. So all of this, underneath this and all this whole area, all of this metal has been, it's what we call the heat affected zone. So it's gotten really hot. Some of the metal from the filler has diffused into this, and it kind of rearranges the molecules in this, and it can cause it to become brittle. So the big thing with welding is you don't want too much of that. If you get it brittle, you'll have a pretty looking weld, and then when you do this, you start bending it, all of a sudden it just breaks. And that was really important, and that's the reason we chose the 70, is because everything I read says that it's just a better material. It's more ductile. Things can flex more without tearing and cracking. So that's pretty important. So another thing was our Tig Welder. So we were running, let's see, what was it? We had this material, the tubing we're running is 095, and whether we were doing tubing to tube or tube to plate, the plate was 1/8 inch thick. But I had my Tig Welder set up to 125 amps, which is quite a bit. And my theory, this is just kind of my style of welding, but when I weld something, I always crank the amps up fairly high. And when I start a weld, I'll basically establish an arc, make sure everything looks good, and immediately I'll just kind of like driving a car. I'll just floor it, hit the pedal to the floor, max amps, and just throw a bunch of heat into it really quick. And that's how I welded all of this. So when I was welding, let's see if I can go back to some of this. Yeah. So when I was welding this, let's see, get the part up here. Come on, sorry. Anyway, when I was welding this, yeah, you see these little like big fat dimes laying here. Let me zoom in. All right, so like say here's one, here's one, here's one, here's one. So as I was going around welding this, I would basically put down a bead like right there, and then when I go to the next one, I would start my arc, get a little bit of heat, and then just stand on the pedal. And as soon as I would stand on the pedal, I would jab a bunch of filler down in there because I was trying to I wanted to melt filler and then the filler melt into the metal. I didn't want to melt the two metals where they fuse together, because if these two metals fuse together themselves, that'll be brittle. So what I wanted to do is just heat them up enough. Right as they start to melt, I put filler in there, and then the filler, I would dump all the heat into the filler, and then the filler, it melts first, and then it melts into the pipe, and then it melts into the base, and I just keep adding filler, and I basically build up, kind of like building it from the inside out. So like I have like this pure filler running through the center of the weld, and that filler is diffusing into this material, and then the filler is diffusing into this material, and what I don't have is, say, chromoly to chromoly or chromoly to mild steel diffusing into each other. That was the key. And like I said, by using a lot of heat, it allows me to do this quickly, and I think that's kind of important. Now, I'm not a professional welder, but I've seen a lot of welds where you put too much heat into it, and that really screws up the heat affected zone. So my thought was, get in there, jump on the heat, weld it, and get out. So, make it quick. Try to minimize how much heat you put into it, because if you think about it, I was at 125 amps, and I mean, I could do this in like 1 second. Something like one of these beads. This whole process is like 1 second. You basically stand on the pedal maybe for like, I don't know, 0.3, 0.4 seconds. And by that point, you're just jabbing filler in here. It goes quick. But if you had less amps, you'd have to stand on it, say 100 amps. You'd have to give it more heat you'd have to give that same amount of heat for a longer period of time. And the whole time you're putting heat into it, heat's heating up this way, and heat's going into your plate in all these different directions and back through your weld over here and diffusing. So there's a point where if I was putting like, say, 20 amps here, it would just never work. All I would be doing is heating everything up, and it would never be enough to weld. So my thought was lots of heat and get it done quick. And it worked out well. Let's see, since we're doing everything in a goofy order, we'll go back to the beginning. So when I showed you this part like this, what I didn't show you was before I actually welded this out all the way, I did tack welds. So what I do is I'll do a tack like, say, here, rotate 180, put a tack over here, and then I'll do a tack here and another one 180 out. And by doing that, I end up with a tack on every 90 degrees. And I did decent sized tacks. Same strategy I was talking about a minute ago. It's easy to do fusion welding for tacks, but I knew I don't want 4 brittle spots here, because what we saw from testing earlier, if you remember, once a crack starts, it's very easy for a crack to spread. So had I fusion welded, say I did 4 little tack welds where I did fusion welds, but then I went back and welded all of this out, I would still end up with 4 little brittle spots. Now you wouldn't see them. Once you weld over those, you'd never see them. And in fact, that would have been easier to do. Had I just fusion welded this, when I put my main weld around this, it would have been easier. So it was tempting to do that, because I've done welds like that before, but I knew for this, I didn't want this to be brittle. So even when I did my tacks, I stood on the pedal and jabbed some filler in there and really tried to, make my tack have the filler metal and not just fusion welding. So all of these things are important, and I kind of realized we went through all this testing. I mentioned a little bit here and there about bevels and stuff like that, but I showed you all these testing, I showed you the results, and I didn't actually tell you the details of how I did it. So I figured that would be today's video, just going over all the techniques, the setup, the machine, and so forth. As far as things to improve, this is probably one of the biggest ones if I really had to change. My 2 thoughts are, 1, this tungsten. I may need to go up on the diameter of this tungsten. I don't remember what this is. I want to say it's like 3/32, or I don't really, that's probably wrong. But I have a feeling that maybe this tungsten's too small, and I am certain this cup's too small. I was using a number 6. I definitely need a bigger cup. Like I said in the video, this humongous one, for whatever reason, wasn't working out. But I can definitely say when I get ready to do my cage, I'll do some practice welds, but I'm going to get a bigger cup on here. I think this little one should really be reserved for when you need a cup that small. When I was doing welds like this, so I mean, you guys saw like this weld, when I did this, fillet, sorry, it keeps jumping, there we go. That's bigger than the cup in this video. That little cup was maybe from here to here, and you can see all this gray. That's all oxidation, because I just could not keep this shielded while I was welding. It's just, I didn't have enough gas coverage. So I know that was definitely a point I could improve, and that would strengthen the welds a little bit. At least a little. I don't know how, I think it's mostly aesthetic, but I know on some stuff that does matter. But that's something that I'll be changing. I'll be getting a bigger cup. And I may experiment with the gas flow a little bit, but my general experience with that is as long as you have enough, it's not a problem. Let's see. Trying to think if I missed anything. Yeah, I guess the only other thing I would mention was the testing phase of all this. So by chopping all this up and, using a vise to hammer on stuff, I mean, that's a pretty simple, pretty much anybody can do that. You just need a vise and a hammer. So no specialized equipment required. It's really just the, I guess, cutting it up. I did have a bandsaw, like a little portable bandsaw. That's actually it in the background back there. And that is pretty nice to have. If I didn't have that, this would have been basically impossible to chop all that up. It'd take forever to use a hacksaw. I wouldn't tell anybody to do that. But yeah, this has been kind of eye-opening, to go through and learn all this. And I definitely recommend, if someone's going to build their own cage, or if you're building something where it's really critical, like say you were building suspension components on your car, maybe motor mounts, something like that, something where it's really important that those welds hold, doing a little testing can go a long way. I actually have a story. A buddy of mine, who's probably not watching this video, but a buddy of mine, when I was in college, he actually was welding for our race car team. And he had some really pretty looking welds, but one thing I noticed was he didn't put any heat. He was basically just stacking a row of dimes on top of the metal. It wasn't really melting in. And one day I finally pointed it out. I was like, hey man, these welds are pretty, but they're not strong. And finally I got him to agree. I was like, look, let's both weld something and beat on it with a hammer and see what happens. And it's what I thought. So basically when he welded his, we hit it with a hammer once and it just broke. And then I welded one and he beat on it forever and eventually gave up and said, okay, I see what you mean. And, he went and read a book. This dude's a genius. And he went and read some books, and immediately, like within a week, I mean, he was just welding better than I was. But, yeah, testing stuff goes a long way. And to me, welding is something that when a weld looks bad, you can kind of know it's bad. But some of this stuff, it can look good and not be strong. And if you look at, for example, in the aftermarket, headers and things like that, you'll see some stuff where they look pretty and they crack easily. So don't be fooled. If you're doing this stuff yourself, don't be afraid to test things and try stuff out. It's all part of learning and becoming a better welder. That's what I'm doing. Like I said, I'm not a pro. I didn't go to welding school. I had a welding engineering class in college, but as far as an actual welding class with a welder, I've never had it. I'm self-taught. I read books and a lot of practice. Lots of practice. So don't be afraid to try something. And, a little bit of experimentation can really answer your questions and help you improve. All right, guys, I hope y'all enjoyed this. Y'all take it easy.